Hi everyone, and welcome to my channel. Today, we're going to be talking about how electric cars work. Electric cars are becoming increasingly popular, and for good reason. They're more environmentally friendly than gas-powered cars, and they can save you money on fuel costs. In this video, I'll explain the basic physics behind how electric cars work. I'll also talk about the different components of an electric car, and how they all work together to power the vehicle. By the end of this video, you'll have a good understanding of how electric cars work, and you'll be able to decide if one is right for you. If you're new here, make sure to hit that subscribe button and turn on notifications so you don't miss any of our future videos. The basics of electric cars. Electric cars differ from traditional internal combustion engine vehicles in a few key ways. First, electric cars use electrical energy stored in their battery packs to power the electric motor. Traditional internal combustion engine vehicles use gasoline or diesel fuel to power their internal combustion engines. Second, electric cars do not have a transmission in the traditional sense. The electric motor is directly connected to the wheels, so there is no need for a complex system of gears to transfer power from the engine to the wheels. Third, electric cars produce zero emissions, while traditional internal combustion engine vehicles produce pollutants that contribute to air pollution. Fourth, electric cars are much quieter than traditional internal combustion engine vehicles. This is because electric motors do not produce the same level of noise as internal combustion engines. Fifth, electric cars can accelerate quickly and have a high top speed. This is because electric motors can produce maximum torque immediately, while internal combustion engines need to rev up to reach their maximum torque output. How electric cars work in detail. The battery pack stores electrical energy that is used to power the electric motor. The battery pack is made up of a series of individual cells that are connected together. The electric motor converts electrical energy into mechanical energy that is used to turn the wheels. The electric motor is connected to the wheels by a driveshaft. The controller regulates the flow of electrical energy from the battery pack to the electric motor. The controller also controls the speed of the electric motor. When you press the accelerator pedal, the controller sends a signal to the electric motor to increase its speed. The electric motor then rotates the driveshaft, which turns the wheels. This causes the car to move forward. When you release the accelerator pedal, the controller sends a signal to the electric motor to slow down. The electric motor then rotates the driveshaft in the opposite direction, which slows down the car. Electric cars are a relatively new technology, but they are becoming increasingly popular. They are more environmentally friendly than traditional internal combustion engine vehicles, and they can save you money on fuel costs. If you are considering buying a new car, an electric car is a great option. Types of electric vehicles. In addition to the basics of how electric cars work, there are a few different types of electric vehicles that you should be aware of. Plug-in hybrid electric vehicles, PHEVs. PHEVs are a type of hybrid vehicle that has both an electric motor and a gasoline engine. The electric motor can power the car for a limited distance, and the gasoline engine kicks in when the battery is depleted. All-electric vehicles, BEVs. BEVs are a type of electric vehicle that does not have a gasoline engine. They are powered solely by an electric motor and battery pack. Hydrogen fuel cell electric vehicles, FCEVs. FCEVs are a type of electric vehicle that uses hydrogen fuel cells to generate electricity. The hydrogen fuel cells react with oxygen to produce electricity, which powers the electric motor. Each type of electric vehicle has its own advantages and disadvantages. PHEVs offer the best of both worlds, as they can be driven on electric power for short distances and on gasoline power for longer distances. BEVs are more environmentally friendly than PHEVs, but they have a shorter range. FCEVs have the longest range of any type of electric vehicle, but they are not as widely available as PHEVs or BEVs. Which type of electric vehicle is right for you? The best type of electric vehicle for you will depend on your individual needs and preferences. If you need a car that can go long distances, then a BEV or FCEV may be a good option for you. If you have a shorter commute, then a PHEV may be a better choice. Ultimately, the best way to decide which type of electric vehicle is right for you is to test drive a few different models. This will give you a chance to experience the different types of electric vehicles and see which one you prefer. The science behind the battery. The battery pack is the heart of an electric car. It stores the electrical energy that powers the electric motor. The battery pack is made up of a series of individual cells that are connected together. How the battery charges. The battery pack can be charged by plugging it into an electrical outlet. The electrical current from the outlet flows through the battery pack, charging the individual cells. The charging process can take several hours, depending on the size of the battery pack and the power of the electrical outlet. It uses a standard household outlet to charge the battery. Key components of an all-electric car. Charge port. The charge port is where the electric car is plugged in to be charged. DC-DC converter. Electric traction motor. Onboard charger. Power electronics controller. Thermal system. Traction battery pack. Transmission. How these components work together. All of these components work together to power an all-electric car. When the car is plugged in, the onboard charger converts the AC from the household outlet into the DC that is used to charge the battery pack. The battery pack then stores the electrical energy until it is needed. When the driver presses the accelerator pedal, the power electronics controller sends a signal to the electric traction motor. The electric traction motor then converts the electrical energy from the battery pack into mechanical energy, which powers the wheels. The thermal system keeps the battery pack at a safe operating temperature, and the transmission transfers the power from the electric traction motor to the wheels. These are just some of the key components that make up an all-electric car. As electric car technology continues to evolve, we can expect to see even more innovative and efficient components being developed in the future. Conclusion. In this video, we have discussed the basics of how electric cars work. We have also discussed the different types of electric vehicles, the science behind the battery, and the key components of an all-electric car. I hope this video has given you a better understanding of how electric cars work. If you are interested in learning more about electric cars, I encourage you to do some research online or visit your local dealership. Thank you for watching.